Okay, in another situation, different safety stock levels will be generated for different services. Well, sometimes the relationship is not linear. So if the safety stock is not linear, we can write our equation in a different manner. So again, we fall back on what we know about our normal distribution. We know that our safety stock is equal to x minus the mean, which is our error again, x minus the mean. So z is equal to our safety stock divided by sigma. So our safety stock is equal to z sigma. And so we know that our sigma is 10. So now all we have to do is vary the our normal distribution level, and we'll get a z value. So here is a table of safety stocks at different service levels. So as you can see, we have service level 90% all the way to 99.9%, and we know that these values represent the area under the curve to the right of the z value presented here. And then once we get the z values, then we can compute our safety stock given our standard deviation. So here's a graph of what it looks like. And as you can see, as our service level increases, what happens to our inventory carrying cost? Well, it increases also. But we knew that, but look what happens as we get closer and closer to 99. The curve becomes what? Straight up. So we're going to be going straight up. So now we want to look at three different situations involving calculating the lead demand time and the standard deviation. And you'll see problems associated with this concept. So there are three situations to consider. When demand is variable but lead time is constant. When demand is constant but lead time is variable. And then of course the natural consequence would be when both demand and lead time are variable. So when we want to look at these three different situations. So our first situation, when demand time is variable and lead time is constant, our reorder point is going to be the average demand times the lead time plus z times the standard deviation of that average demand times the square root of the lead time in days. So in this case, we're going to get z from our table that we saw earlier. We're going to know what L is. We're going to know what our average demand rate, and we're going to have to be given the standard deviation. We're going to be given all these pieces to the puzzle, and from this point we can compute our reorder point. Now, what happens when demand is constant but lead time is variable? Demand is constant and lead time is variable. So note where we have to go with the average lead time and the standard deviation of that lead time still give us the level, the service level that you want, and we know what D is. Now we have to take the average lead time and the using our Z multiplied times our daily demand. Okay, now last case, what if I don't know both? What if both lead time and demand time are variable? So if lead time and demand time are variable, now we take our average demand and our average lead time. Our Z stays the same. Give me a Z. We take it to the table and find the Z value. And now we have our standard deviation. Not our standard deviation. We have our variance associated with the demand times our average demand, our average lead time. And we have our demand squared times the variance of our lead. So we have three different models that we've looked at. So now let's look at an example. So here's a product that's daily demand is normally distributed with a mean of 15 units. My mean is 15 and the standard deviation is 3. The lead time is exactly 4 days. So we know what the lead time is. To maintain a 97% service level, what is the reorder point and how much safety stock should be carried? All right, so we look at this model, we see that we're given that our average demand, which is 15 units, our lead time, which is exactly 4 units. We look up the Z associated with 97%, and that's 1.88. And then we have our standard deviation, which is 3, times the square root of the lead time. Square root of 4 is 2. And we have all the information to put into our puzzle, and we're able to solve. The reorder point is 71.28. So if we look at this model, we know that this part back here is our safety stock. So what's our safety stock? Well, simple. Our safety stock becomes 11.28 units. Now suppose that the demand is constant, but the lead time is normally distributed with a mean of 6 days and a standard deviation of 3 days. Do we have all the information to solve our problem? Yes. Because again, our basic reorder point formula is our demand times our lead time. At this time, our lead time is variable. So we're going to take the average lead time, which is 6 days. Our demand is 25 days. Our Z associated with 98% is 2.05 from the table above. And then our demand, which again is 25 times the standard deviation of our lead, which is 3. And again, we're off to the races. Our reorder point occurs at 303.75. And if we look at the back part of it, then we see that our safety stock includes 153.75 units. And in our last model, look what happens. Now we know that the daily demand is normally distributed with a mean of 20 units and a standard deviation of 4. And the lead time is also normally distributed with a mean time of 5 days and a standard deviation of 2 days. To maintain a 94% service level, what is the reorder point? We have all the information that we need. We know what the average demand and what the average lead time is. The average demand is 20 units and the lead time is 5 days. We know that Z associated with 94% is 1.55. We have our mean lead time, which is 5. We have our variance squared, our standard deviation squared, which is our variance, 16. And then we do our average demand squared. Our average demand is 200. 200 squared is 400. And our standard deviation of our lead time is 2. 2 times 2 is 4. And now we have a simple algebraic expression. We know that this part over here represents our reorder point, which would be 100, but we have to add our safety stock, which becomes 1.55 times 40.99. So as you can see here, our reorder point is at 163.53, with our safety stock being 63.53. Okay, so now we can calculate the annual holding cost with safety stocks. So under the standard assumption of the economic order quantity, the average inventory we claim is Q divided by 2. So the average holding cost is our average inventory times the cost for holding. So this is not the case with safety stock, because we don't draw down safety stock. Safety stock is there to use in case we have to use it. So calculating the annual holding cost of safety stock, okay, is used by the equation below. So now, well, what do I have? Well, you have to give me all the pieces to the puzzle. You have to give me Q, you got to give me 2, you have to give me the cost for holding, the safety stock, and again the cost for holding. So the total annual holding cost is equal to this value as long as you give me these numbers. Okay, so Excel for QM gives us this information. Again, all we have to do is put the information in the correct place, hit the button, and we will get the information that we need. Okay, and here's an example, and I will leave it to the individual to go through it.